All right, so hopefully everyone can now see my introductory slide. And I want to start off with this slide because I was giving a lot of thought to how I'd approach this talk and what I would do. And I like walking Mount Doug with my two buddies here and my wife. And, we appreciate, the land that we're on and all that's come before us. And that started me thinking about memories. And when I was thinking about memories, I was, going, God, it's great living here. And then I wondered, who is the God of memory? And actually ends up being the goddess of memory. It's Mnemosyne. And so for those of you who don't know, let's see if my screen will now change. Mnemosyne is a Titan and also the goddess of memory. And so it shows us for a long time, people have known that memory is an important attribute. It's something that we need and consider to be a central aspect of our humanity. It's intrinsic to our self-identity, but it's something we're also very aware of declines with normal aging. It's only when it's really disrupted aberrantly that we become concerned, whether that's through traumatic brain injuries or as part of the aging process where we start associating it with the dementia, right? I think we all worry about losing our memories, and by age 80, you see from the NIH sign here, about 20% of our nerve connections to the brain's memory centers can be lost. So there's a normal degradation of the brain over time, and that can help, or that can facilitate the disruption of a lot of our memories. So when I first started this work, I was more on Stephanie's end of the spectrum, where I was looking at molecules that are important for memory. And in particular, I was looking to see if your brain produced new cells in the adult brain. That's something we knew happened early on in development. We weren't sure about this in the adult brain. And I got involved with a group that started putting this green fluorescent protein into those stem cells Stephanie was talking about. And we're able to not only show, but record from these cells in the brain and show that they were actually becoming functional neurons that were important for learning and memory processes. And we went on to actually look at the development of these cells in the adult brain and how they became part of a brain that was already formed and functioning, how they integrated themselves and enhanced learning and memory processes. When I first started my work at UVic, I was really intrigued with this protein called brain-derived neurotrophic factor, or BDNF. And we thought it was something that was really going to be a key to improving memory. Its reductions in BDNF are associated with dementia, cognitive impairments, anxiety, depression. It's been shown in disorders like fetal alcohol syndrome and a lot of addiction disorders. Conversely, if you increase brain-derived neurotrophic factor levels, you increase neurogenesis, synaptic plasticity, and it had the potential to be a therapeutic for all of these conditions. So this was something I was intrigued with, and we started a series of studies at the time with one of my graduate students, Joel Farmer. When we first finished our first set of studies, I went to a meeting much like this one, actually, and gave a presentation on our work with BDNF. And in the audience was an individual from the University of Montreal. His name was Jocelyn Faubert. And he was talking about his work with video games. And he saw this video game of his as a way to enhance performance in high performance athletes, right? So he was working with teams like the Vancouver Canucks, and he was looking to enhance their ability to play at a high level and to get an edge over other teams. He worked with, high-end soccer teams, Manchester United, with football teams. I think Tom Brady works with him. So there's an aging brain that uses the technology with great success. So a lot of high-end athletes were using this, but he came to me with a question, can you look at these athletes and say if maybe my game is actually producing brain-derived neurotrophic factor in their brains and enhancing synaptic growth and neural stem cells? So he introduced me to this game, and it's a 3D multi-object tracking video game, and I'll give you an example of it in a little bit. But basically, you sit in a chair looking at this virtual cube where there's going to be a lot of balls bouncing around. And you're going to have to remember some of those balls, and the other ones serve to distract you from tracking the ones that you're after. It's used by elite athletes to help them train their focus and attention in complex environments. And again, we're going to see a BDNF increased, if Neurotracker increased BDNF levels in the brain. Little did I know, I was actually going to end up on a different journey where I began becoming engaged in patient-oriented and led research rather than looking at molecules. So part of the journey involves working again with Mnemosyne. And if you don't know, Mnemosyne was also the mother to the Muses, the goddesses of arts and science. And my work with memory introduced me to my own Muses. And these are individuals who have worked in the laboratory throughout the years and have really inspired a lot of the research I'm going to talk to you about. And these include, early postdoctoral candidates, Christie and Kowalski and Lindsay G, Julie Irwin, who's doing her PhD. We had people from all over the world come and visit us. Erica came up from University of Washington. Stella came from Italy. Carolyn from Toronto. I'm going to talk a lot about Taylor, who did some amazing work with us. We've had a lot of success stories. Kim Oslin, who is not only an Olympic trainer, but is now runs the athletic program at St. Michael's University. Alison Rodway, who is also a trainer for the University of British Columbia, Olympic teams. Again, another team they're showing at conferences where they got a lot of attention. And also started engaging in collaborations with other faculty at the university. Chantaneja, who's a pediatric neuropsychologist, Jody Garluck, who you're going to hear from later on, Mauricio and Lynette in psychology and exercise physiology. And we got exposed to hundreds of graduate student volunteers and, hundreds, and I would say even now thousands of residents and donors who have been involved in the program. So we really became engaged with this program. So what is Neurotracker? Well, it's a game that really involves effortful processing. It involves all regions of your brain. The frontal lobe, which is important for attention to the task, predicting future movements of the balls and planning your responses. Your parietal lobes involved in the integration of the visuals input from other senses, reconstruction of that 3D environment. The temporal lobes helps you remember the original targets and it updates target information. And your occipital lobe is involved in that visual processing of this task. So you use your entire brain simultaneously, interconnected while you're doing this task. So now we're going to do a quick little audience participation. And the whole point of Neurotracker is to focus on these 8 yellow balls that are going to appear on your screen. 4 of them are going to turn orange. Those are your targets. They're the 4 you want to remember. They're going to turn yellow again. And you have to remember which were the ones that turn orange while they bounce around on your screen. There's going to be 4 more balls that only stay yellow. They're going to be bouncing around too. They're the distractors, okay? So we'll start off at your average university athlete speed. We won't go that slow. So this is a speed of 1. There's your targets. Now they're going to start moving around on your screen. Oops. And I guess because of the internet, it's going to be a little glitchy and buggy, but you can see they're bouncing around, and when they're moving in a nice, smooth fashion, this ends up being quite a difficult task to do. And so you have to identify which they are, then the program will tell you which are the right ones. If you get it right, it's going to go faster. If you get it wrong, it's going to go slower. So it actually adapts, the program adapts to your learning capacity. And that's what makes it effective. It continually pushes you to do better. So I'll try the 2.0, see if it works on the screen. I don't think it will because of the glitching, yeah. So this is double the speed. This is something like Corey Schneider, the Vancouver's ex-goalie, who I met in the beginning, would do it at this level. And it's really fast. It's really hard to do. With significant training, I was barely able to get up to this level of 0.2. But it's not the best that people have done. In fact, Taylor's had athletes who have come in from the University of Victoria who have done it up to levels of 4, which is exceedingly fast. The point is, no matter what your age, your athletic ability, your visual perceptual ability, you are able to improve and to learn if you do this task. And when Neurotracker came to Victoria, we started getting involved in the community, and the community really started affecting how we use Neurotracker. We work with girls teams, boys teams, Olympic athletes, Olympic athletes, people with the Victoria Brain Injury Society, youth sports teams, my kids' teams, with the people through the Institute for Aging and Lifelong Health. The Royals, came using, the Vikes came and used it. So we got into the community and they started shaping what we were doing. And one of the first things that we noticed through our interactions with them and through our interactions with high performance sports teams is that people with a certain type of brain injury were having difficulty with it. And these are people with concussions. And so one of our first tasks was to look at, what was it about concussions that was affecting Neurotracker? And so we started a study where we began doing mass concussion testing across all these junior sports teams, university sports teams, junior hockey teams, etc. And we give them these SCAT3 tests, which are ways in which you can baseline test individuals before they get a concussion and then look at them again when they have a concussion. At the same time, we also started giving them Neurotracker training so that we could look and see how Neurotracker training related to the SCAT3 testing that we're doing. And what we found is that it related very well. Individuals who had SCAT symptom scores, who actually were showing signs of a concussion, did very poorly with Neurotracker. Individuals who didn't show concussion symptoms did really well. And I'll move on to the next slide because I think it summarizes it better. And so here, whether we're looking with males or female subjects, what we found is if you had no history of concussion, didn't have any symptoms, you could do very well in the test. In fact, here you're around 1. That's what people trained up to over time, irrespective of age. And these are all subjects 13 years of age and older. If you looked at people who had concussions but weren't having symptoms, and that's in the blue bars, you can see that they also did very well, both males and females. They didn't perform any differently from individuals who hadn't had concussions before in their lives, right? They aren't showing any symptoms. They're responding like normal individuals. But if you had a concussion and you did have symptoms, if you had headaches, nausea, vertigo, etc., of course, your performance on Neurotracker was significantly impaired. And that was for both males and females. And you are significantly impaired compared to both groups. People who had never had a concussion and people who had had concussions but weren't symptomatic. So this really gave us an idea that Neurotracker may be a good diagnostic for concussions. But we also had some other evidence coming in. We had people who had long-standing concussion problems who kept coming back. And so we started asking them, why are you coming back? And they said because the next few hours after they did Neurotracker training were the best hours of their day. They felt like Neurotracker was doing something to help them, and they were able to accomplish tasks in the normal daily life a lot easier after undergoing Neurotracker training. So we began to investigate this. And one of the first to investigate was this student, Carolyn Spainer. And she was an undergraduate student at the time at the University of Victoria. And she came up with this interesting idea that maybe Neurotracker's benefits are because it does something with attention. And so she actually started off with a project, can cognitive training improve attention and daily functioning in the elderly? And to look at attention, she used this task called the Stroop task. And she thought that looking at attention was very important because as attention levels decline with age, it affects your ability to perform a lot of tasks, including things like driving, reading, memorizing, playing cards. Attention is important to all these things. And if you just look at driving, the result of losing your driver's license can be, incredible on someone's health. You can create depression. You can get declines in just your general health. It increases your mortality, and of course, your life satisfaction is lower. So increasing attention may be a way to do simple things like help people keep their driver's licenses longer and be better drivers as they age. So she did the Stroop task, and there's basically 3 components to it. You either read the color name, blue, pink, yellow, green, red. You name the color of the words, blue, brown, red, purple, green, or you just read the names of the colors, red, pink, blue, orange, yellow. And you can tell it's easier to do some of these things, like the third, than it is the second one, right? You have interference in your brain, so you have to really attend to the task to do it right. and you look at how many errors people make when they do this and how long it takes them to do the task correctly. And what she found is prior to any interventions, not interventions, sorry, I apologize for that. As you got older, your performance on this Stroop task actually decreased. So your attention level caused, a decreased attention level caused you to make more errors. And so then she had people engage in Neurotracker training for 5 weeks. What she found afterwards was everyone did a lot better on the Stroop task. In fact, the elderly group, 74 plus, that was worst on the task actually improved so much they were the best on the task at the end of this. This was just a little, undergraduate directed studies project, but it really created a profound impact both on Carolyn Spainer and myself. Carolyn Spainer is now in medical school and is going on to become a gerontologist. So it really directed her attention at what can I do for an aging population. And for us, it started us thinking about how Neurotracker training could enhance cognition in elderly populations. And this is when Stella joined our lab from Italy. And this is Stella's favorite picture. That's why I have it up. We got her, and Carolyn was still in the laboratory at the time, and we went to a conference. And I said, hey, do you guys want to get ice cream? And she's like, what? And she had never had one of her professors just buy her ice cream just for the heck of it before in her life. And so she's got this on her Facebook page and everything. She's a wonderful girl who also came up with a wonderful study. And what she wanted to do was look to see if Neurotracker training could enhance cognitive functioning as you get older. And she used 2 tests. Being a clinical psychologist, she had access to something called a comprehensive trail making task. And this is how you have people figure out how to follow like numbers in a low. And so you just have to connect 1, 2, 3, 4, 5. A more complex one would be to interspace numbers with letters, 1, A, 2, B, 3, C, etc. And you can have these circles all over the page. So that's a trail making task. And she also did verbal learning and memory tasks. And this is when you have to read information and retain it and then remember it for questions later on, right? So 2 different tasks. And here's a picture of Stella. She actually just got married last weekend. This is her new husband and her son, Albert, at the wedding. So in Stella's first task, she found that the experimental group and the control group both performed equivalently prior to any trail making training. But if you look after training, there's a significant enhancement in the elderly group that we didn't really see as much in the control group who hadn't had any training. With verbal learning, same sort of pattern. Prior to training, we saw enhanced verbal learning post-training as compared to the control group where we didn't see any changes. So in both contexts, there was facilitation of their capacity after Neurotracker training. And I'm sorry, my timing's been a little off with the storytelling. I'm going to have to get rushed through Taylor's story. She took Stella's work and Carolyn's work, but applied it to a patient-oriented research with Victoria Brain Injury Society. And I'm going to rush through, just tell you that she did this cognitive test, training, and then cognitive test, not only immediately after, but 1 month later. And what she found is that even people with significant brain injury can learn the task, perform better at it. And if you look at their performance on tasks before and after Neurotracker training, they had much lower symptom scores after training. And if you look at their abilities in verbal memory, they were significantly improved after Neurotracker training. So it looks like this task does do something to enhance cognition and functioning in the elderly. And she has an amazing project that's planned. It was delayed because of COVID, but now it's up and running and she's getting things online again. And I hope that those of you who are interested can take part in the study. And with that, I'd like to thank Taylor and her team and all of my muses, past and present, for helping us. Thank you very much.